Alright guys, let me talk to you about what I'm thinking. Close window. Stop listening. Alright. So, I have here this flexible, cool thing, which has a chuck on the end. And this is supposed to go on your drill, and then that makes this turn. But I wanted to put this onto an industrial die grinder that goes, is that right? 26,000 RPM. I wanted to have it on this so it goes 26,000 RPM. Can you imagine having a conical sander? Where the heck is my conical sander? Well, here's one of them. Can you imagine having this cone-shaped sander turning at 26,000 RPM? You'll be able to cut through anything, metal, whatever, like super fast. And the point of that is for sanding things, like sanding and shaping fiberglass. It would be amazing. So I would just hold this like this, and I'd just be like, and I just clamp down with like a vise, whatever fiberglass I'm wanting to sand, and I just use my left hand, just and it would just cut through it like butter. I could just imagine a big wall of fiberglass that this is going to pass through. It would just cut it like this, just cutting it right in half. I mean, that it's going to be spinning retardedly fast. But the problem is, none of these go together. This chuck isn't designed for a shaft this big, so I have to create a coupling system where I put a smaller shaft in here, and then I use one of those couplers that attaches a servo motor for a 3D printer. No, it connects a stepper motor output shaft to a lead screw, and it has a little screw that makes it clamp down. So I'm going to put a little metal shaft in here, and then one of those couplers from a 3D printer to clamp this down, and then these will be mated. But then I also have to mate this. This has a pretty small output shaft, and I have to mate that somehow to this. And I'm thinking about removing this bolt, finding a bolt with the same threading, and screwing it down, shaving off the bolt head, and then shaving the threads smooth, and then using a coupler onto that to couple it to this. And I have the couplers, I can do all of that, but I was just telling you what I was thinking. I'm just kind of giving you my review of my plan. For me to have a wand like this that can turn at 26,000 RPM with an industrial grinder powering it, and I can just cut through anything, that's going to be the ultimate sculpting tool for subtractive method shaping of things. So after I create my fiberglass fabricated part, I can really smooth it out so fast with this thing. This will be the ultimate sander. The reason I don't want to use the grinder itself is because it has a fan connected to its motor that blows at high speeds and it shoots dust everywhere. But I want to contain all the dust, and I don't want a fan blowing in there. I want the vacuum chamber to suck all of the dust in, and this wants to kick dust at high speeds everywhere, even higher speeds than the vacuum can rain back in. So the dust particles end up escaping the vacuum chamber and entering my room, and then I breathe that in, and it covers all my stuff and it damages my computer. So I want to be able to use a high-speed grinder without having the grinder anywhere near where I'm using it. And so a flexible extension shaft is perfect in order to use the grinder. Also, you don't have to deal with the weight of the grinder because you're just holding this little lightweight shaft that only weighs less than half a pound, so it's a lot less strenuous than holding this big heavy thing in place, trying to use it. Like, that's really hard on your shoulders after about an hour, and I want to be able to grind all day long. So I would keep this grinder on the floor and use the flexible extension hose to actually do the grinding, using this thing's power. Absolutely, it'd be stable with a coupling system. It's not going to need to make much torque at all. It's not going to put a lot of pressure on the couplings because it's just a high speed application. It's just for sanding, a sanding bit. Guys, I've been using power tools since you were born. Don't tell me how it's done, I'll tell you how it's done. Okay. So now I'll need a screwdriver. Interesting. What happened with my arm? Well, I sprained it kayaking. And shoulder injuries need to be kept in slings if they're bad enough for a long time. this even doing anything? Oh, cool. It's some kind of slip joint. So basically, if something were to bind on here, the machine won't rip itself to pieces. Um, if if anything puts a lot of pressure and stops this from turning, the machine will still continue spinning. So that's a safety feature. So this machine is not designed to transmit all of its torque. It's only designed to spin things that aren't requiring much torque at a very high speed. Otherwise it'd be super dangerous. That's fascinating. I didn't realize that. What a great design. That makes this thing totally safe and indestructible. I guess you'd call that a torque converter. A friction-based torque converter. That's how some transmissions work. My arm got hurt about 5 weeks ago on a kayaking trip, and now I have to keep it in a sling for another week. Actually, it was 6 or 7 weeks ago. Okay. So the next thing we need is a bolt, like this one. Oh, let me go see what the coupling would do. I don't know if you can stick this whole thing into a coupling or not. I better make sure, because that would be way less work than trying to make some kind of output shaft for it. But I might be able to find a bolt too. I'm just gonna see what my options are, see what we're dealing with. I need to get those couplings out. Be right back. Okay guys, I figured it out. Let me just talk to you guys about what I've been thinking and what I came up with. Okay. You're gonna love this. So basically, we've got this this rotary tool here, and it has a output shaft that you're supposed to put this screw into, and it tightens down onto 2 washers you put on first, which are right here. I'll just show you how you do it. So you put on the 2 washers, and you would put your sanding drill disc on between the washers, some kind of disc. Then you'd shut this one on it, and then you'd screw them down. So you'd have your sanding disc right on this industrial die grinder. But we don't want to put the whole weight of this industrial die grinder in our arms the whole time. We want to use this extender right here. It's a flexible extension hose, and then this is what we'll actually be holding onto to grind. When this thing turns, this bit turns, because it's like a snake. It has a piece of wire that just turns with it. So the key here is how do we get this to mount to this? So then I came up with using one of these couplers that comes with a stepper motor for a 3D printer. And that will work, but we would need to find a screw that just matches this. Same thread pitch, same size screw. And then screw it into here, cut off the top of the screw, the head of it, so that it just is a pair of threads that screw in, and then it just becomes a smooth shaft. We would cut off the top of it and grind off the threads so it becomes a smooth shaft coming out of here. And then from the smooth shaft, we would use this coupler to couple it down to this size. And there's locking nuts on the side that would lock it all down. So that would work, but we'd have to grind off the head of a screw and find an identical screw with the same thread pitch and everything. And I wouldn't want to damage this original screw, which comes with the machine, because I would want to be able to use it in its originally intended way anytime I want. Especially if this extension hose idea doesn't work or the hose breaks or whatever. So I don't want to lose the original part. So I was thinking, well, what if, since this is a hexagonal shape, we just created a hub around it, and that hub was built nice and thick, and we put wax paper down first, and then we built a hub of epoxy putty. We sculpted it in a torpedo shape, and then we just put a little piece of metal shaft out of that. If we did that, then we would end up with a piece of metal shaft that we could couple to. And since it's a hexagon shape, the epoxy would hold nicely and it wouldn't tear apart because it would conform to that shape. And the wax paper around it would enable us to pull that off. Otherwise the epoxy would bind to this metal. So we'd wrap it in wax paper first so that it can pull off with ease and we could use it whenever. And then when we want to use it, we also can put some tape around the epoxy hub we're going to create just to hold it on from coming off this way. So that I realized that would work. So now all we have to do is create an output shaft that's the right size to fit through here, or find one. Well, here's one. The handle of a little clay scraping tool works perfectly. Maybe we'll use one of the handles we don't particularly care for. Because some of these handles go to tool shapes that I don't really use. Plus, I mean, we don't have to destroy the tool. The handle will just be shorter. That's not a problem. We're putting it to good use. It's a good cause. Okay, so we would use this handle. We just have to cut off a piece of this then. So I'll just mark where I want to cut it with some masking tape. Okay, that piece of tape was a fail. Just gonna get a new piece. Hate when it splits down the center like that. I'm trying to think now while I'm doing this of how I want to cut it. What would be the best? I guess I do want a precision cut. You know, the fastest way will definitely be my angle grinder. Yeah. Angle grinder's always the best. I'll do that outside though. It'll be really loud and wake up my wife otherwise. So that's my next job. To cut this bad boy in half, nice and neat. So I'll be back. I'm not going to do that in the house, and I can't bring my webcam outside. I don't have set up for that at the moment. If you get lost in that phase, just Google how to cut something in half. You know what, actually? Oh, you know what? I could actually cut this in half with a bolt cutter. That'd be way easier. Oh, I'll be done in a second. Holy crap. So I'll be back even faster than I thought. We did it! Oh, I'm just realizing I need to smooth this out, and I don't have two arms really to work with. I had to do it outside with my die grinder. I'll turn the grinder on, set it on the ground, and use my good hand to swipe this across it till it's smoothed out, because it has a lot of sharp edges. So I'm just preparing myself to get up and go outside again in the freezing cold. It's okay. I just don't really feel like going out there. But it's okay. How do I make sure it's true? The bit has to come out perfect. If the output shaft is even off by 1 degree, it's going to cause the whole machine to be wobbling and rattling, and the whole thing might not even work. Well, then again, these couplings are designed to bend a little bit. They have some springiness to them. That could correct for a little bit off. So that's nice, at least. I don't know. I guess I'll just try to get the best I can by eye. I really don't. I don't feel like building some kind of crazy true measurement device. That's a whole nother day of work, man. This is already an extra day of work. I was supposed to be sanding stuff today. And now here I am creating this elaborate sanding system. I could have just used what I had, but I wanted a better sanding method. Yeah, I think it will save me time in the future. I'll be able to sand longer sessions with less muscle fatigue because I'm holding a much lighter. I don't have to hold up a freaking 8 pound grinder. I just hold up a little grinder extension and it still gives the same speed and ultimate functionality as a 26,000 RPM grinder. And I've been using my cordless drill to sand things or grind things. And that thing's got way slower RPM, probably 1,000 RPM. This is 26 times that speed. It's going to be incredibly nice. So I think it's worth it. It's just sometimes pretty annoying how you have to do a project to do a project. I'm like 9 projects deep. I'm building a grinder so I can make more efficiently grinding the custom wheels for my custom automotive pop-up tent, which I'm making so that I can work on my car. And I'm going to work on my car so that I can work on my wife's car. So that once I finish her car, then I can finally work on my car. And I need to finish my car so that I can drive my car to where I'm storing my van so that I can fix my van so that I can sell the van. So I'm like 8 projects deep doing one thing so that I can do the next thing so that I can. It's just really annoying. I'll just shape it while it dries for 10 minutes. The epoxy putty takes 10 minutes. That'll give me plenty of time to make it true by eye the best I can. I think I should be able to do a decent job if I check it from every angle. Well, come on. You know, it's funny. I guess that does sound like life in general. Like, I'm going to school so that I can get a job, so that I can buy a house, so that I can support a family. Everything's like, I'm doing this so that I can this, so that I can this, so that I can this. It's like a chain. You never just get to do the thing you want to do. You got to do the things leading up to the thing you want to do. Never-endingly. Okay. Now what? I decided I'm going to use parchment paper just to make sure the epoxy doesn't stick to the drill itself, because I want to be able to remove this custom coupler anytime later. Oh, come on. So Scotch tape won't stick to it. This will, I bet. This is adhesive transfer type for low surface energy surfaces, and that's perfect when dealing with parchment paper. It's supposed to stick to the stuff nothing else sticks to. And it's working. Okay. Um... Time to clean up a bit. Things are getting a little chaotic on my lap here. This is so funny. This is so stupid. I mean, I guess you have to do weird things like this if you're making stuff. I know some machinists would think I'm retarded though for using epoxy. He would like make a screw for this in his lathe in 2 minutes or something, I don't know. But I'm using what I got, the best I can. I could be a machinist, I could build a lathe, but I don't want to cross into that realm where then everyone that watches me build anything says, well, I could do the same if I had a $20,000 lathe, so I'm just not going to do anything because I don't have the right equipment. If I build everything with hand tools and basic stuff you can buy at the hardware store, like a tube of epoxy, nobody can have an excuse then to be able to be inspired by it and follow what I do. So I try to do everything in the most primitive ways. I built the robot's bones instead of out of foam core titanium steel or whatever titanium. Instead, I built it out of clay and baling wire, and then I coated that in epoxy, and then I removed the clay, and then I fiberglassed it. And you can buy fiberglass at any auto parts store or any hardware store. Same with the epoxy. I use just simple, basic Loctite 5-minute epoxy. Anybody can buy that glue at a hardware store. So I do everything using cheap, readily available techniques with no special equipment. That way nobody can have excuses. When they watch my videos, they'll say, oh, I can do that. And then they'll get excited realizing I can do something that will lead to something amazing. So I think it's good not to get the specialized tools. But eventually I will be doing, I'm going to be making my own welder, my own plasma cutter, and my own CNC machine. So like, I don't know, I guess eventually I will be leaving the... But I mean, people can still see how I did it before I had those machines. But yeah, I guess, I mean, everybody eventually graduates to some extent. Yeah, I'm DIYing, but I'm telling you, I've read some of YouTube comments that say, like, oh, this guy used to be cool, he used to make stuff that I could make, but now he just uses highly specialized machinery I don't have, so now I can't follow along or whatever. And I hate reading that because I want to be able to help people. Uh-oh. I need to score it to give the epoxy something to bite onto. Increasing the surface area, giving it teeth is important. I haven't thought of cutting it flat on one side so it's like a D, and then the epoxy could bite onto that flat wall. Last thing you want it is to be perfectly smooth. Okay. By the way, guys, this is what's it called? Pro Epoxy 20 steel reinforced epoxy putty. It's really good. It gives you 20-minute working time. I swear by it. It's super strong. It's way better than like the Loctite stuff. I'm on my second tube. I use it for a lot of stuff. It's such a valuable tool to have for fabricating anything or fixing anything. And I wish I could raise my right hand up. I want to do this with my right hand, but I can't raise my right hand because of my shoulder injury. Yeah, I know I'm not throwing money at my problems, but it's still like once you have the machine, somebody will say, "Well, I don't have that, so I can't build the things he builds anymore." And that's when it gets sad. This is going to make a hell of a YouTube video. This is going to be such an amazing tool. A flexible shaft 26,000 RPM rotary tool extension system that anybody can make. It's going to be the ultimate for repairing stuff and grinding stuff and smoothing stuff, sculpting stuff, cutting stuff. I'm not making a bit, I'm making an extension coupler. It's going to use one of these couplings with the set screw. It's going to have that go to here. Like that. And then from there I'll be able to attach to my rotary extension tool, which has such a tiny bit, and it doesn't mount to this. This doesn't have a chuck. So I'm making my own coupling system out of epoxy and the handle of a hand tool. The handle of a clay removal tool. Nobody's ever done this before, I don't think. This is going to make a great YouTube video. You don't have to... That's the other thing. A lot of times people will show making something like this using a lathe. Ain't nobody got no lathe. I'd never want to have a lathe. Funny you say that. One small step for man, one giant leap for mankind. Because this actually looks like a space shuttle. This is where guys, this is a spaceship, small scale, and this is where the astronauts stay, and this part detaches. These are the rocket engines, and then this detaches, the second phase, and then this is the lunar lander. It looks like a spaceship. I'm already designing spaceships, guys. You already know I'm leaving this planet. I'll send you a postcard from Mars. It's not a toy! This is serious scientific technology. Guys, I freaking nailed it, man. I nailed it! It's perfect! It is perfect! This is gonna be a sick tool. You guys have no idea, man. 26,000 RPM. And I'm gonna be able to have that in my fingertips. All those years of building robot bones with a drill motor turning my bit. Imagine how fast I'll be able to sand with something 26 times faster. No, it's probably like 15 times faster. It's gonna sand so fast. I'll be able to cut or sand anything, even metal, instantly. Don't you guys realize what I've done? This is an industrial die grinder that I got from my grandma's brother. When he died, I got it from his widow. She had me do some driveway work or something in exchange for a bucket of tools. I gave her a cheap price. I said, I tell you what, I'll knock like 200 off if you give me a bunch of his old tools. And I got to pick out like 10 awesome power tools. And these are top of the line. This is Sears Craftsman. This is old school too. Well made before everything became crap. Because this thing's like 60 years old. It's back when they used to make stuff way better than now. Wait, did I just make a lathe on accident? Oh my gosh, I just made a lathe on complete accident, guys. This is actually a lathe. Oh my gosh, I just made a lathe. My bad. Oops. Check it out. Once I connect this coupling to this, I'll be able to connect any output shaft I want, including like any type of metal, and I can like shape it, and I can even add like, I mean, it's a by hand lathe. I need like the other attachment where you put on screws and then you like move it up and whatever. I could totally do that though. This is a lathe, guys. When this starts spinning, I can like tool this. I'm gonna be tooling all of this actually. I can't believe I have a lathe. I told you guys I would never do that. I accidentally built a lathe. Wait, what do you use a lathe for again? You use it to build like couplings, right? And screws? I built a lathe, guys. Wow. That's crazy. It's gonna be as strong as a pretty decently strong lathe, I bet, too. I mean, what's the point of a lathe? It needs to be sturdy, it needs to be solid, it needs to be fast spinning, right? This has all of that. Most lathes are just huge though. This won't be huge, but if I put a vise on this, I could clamp it to a table sideways like this, and now it's a lathe. It's a mini lathe. I could still use it to make small parts. This will spin evenly. However far off this will be is going to be sorted when I turn it on. I'm just going to hold this next to it, and it's just going to automatically become perfectly true. If it's off by 0.5 degrees or whatever, it's just going to automatically true itself just by holding this thing. That's how lathes work. So I'm going to have a true lathe. Hi, Stolarks. So basically, I removed the bolt off the tip and the two washers, and then I wrapped parchment paper around it, and then I cut off the little handle of a hand tool, and I lined it up, and then I put epoxy putty on it to make a coupler. Now it has a vertical coupler. And now I can use a coupling, like from these servo motors, I can use a coupling to attach to the coupler. And then from that, I can bush down then to this flexible extension hose for a drill or whatever. I'll be able to attach it to there now. And then I'll have 26,000 RPM going into this hand tool with the little chuck on it, and I'll be able to attach grinders and whatever to it, and I'll be able to carve anything, and it doesn't weigh anything. Like the size of a marker, I can use it like a tiny grinding bit I could put on here, and I can like just draw with this thing into metal. It's going to be spinning so fast, I can literally like write my name in metal, like deep. I can shape anything. I can put dental drill bits, and I can get extreme precision, high RPM. I can actually do dental work with this, in fact. I can attach a dental drill bit and actually do dental work. I can drill out teeth and stuff. So yeah, I created basically a dental high-speed thing. And you can use it for... Yeah, flex shaft. You can use it for shaping jewelry. You can use it for sanding epoxy parts that have been roughly epoxied and need burrs and sharp edges taken down. You can use it for shaping, even subtractive sculpting. You can put a sanding bit on and reshape or grind the rust off of car parts. So you can use it for automotive work. You can grind out a bad bolt that's been snapped off in your car. You can put a little grinding head and just grind the bolt. Just drill right through with the grinding head. And I mean fast. You'll be able to burrow through metal so fast it's ridiculous. I mean, the list of uses goes on and on. And unlike this huge tool, you can get this down in your engine compartment and like grind away a part that you can't get a cutter on to cut it off. You can use this to fabricate. You can use this grinder to smooth out welds. If you did a weld and you have a ugly line, you can use it instead of an angle grinder. It's a lot lighter in weight, easier on your shoulders. You can use it overhead just to grind things without holding up a big heavy angle grinder. Especially if you need to grind a bead that's kind of out of reach and you can't get a big angle grinder on it, you can just reach that little tool up into small, tight-fitting areas. No, I'll do my own dental work with it. I'll show you guys. It's no big deal. If I did your dental work, I would be way better than a normal dentist. Because I have way more skill. Actually, I've got some really tiny grinding bits already. I've got dental bits and all kinds of stuff. Here's a really small grinding bit that can be used for fine detail grinding in metal or whatever you want. Here it is. That's a small grinding bit. I can use that on my new grinder. And I can also use bigger grinding bits like this. And I can use little cutting wheels to cut metal. Very high speed, so it'll cut fast. And those are called Dremel cutoff wheels. And I can use these dental bits as well. I've been using all this stuff before. I also have little polishing bits. But it never worked because I never had a high enough speed tool. Here's a whole bunch of like dental bits. Carbide tipped little bits of all different shapes. And I'll be able to use all of that at 26,000 RPM. It's going to be a big difference over using just a drill, which is why nothing really worked that well with my drill. This is going to be a whole new league. I'll happily stream doing my own dental work. Which are super powerful. Ooh, it's hard! What do I do next? I guess I can set it down now. It's hard. I mean, it's hard. I think it's fully cured. Let's see. What is next? I think next I'll sand it, but I have to set up my vacuum chamber for that. I don't want to make a big mess. Oh gosh. Okay, I gotta set it down first. What's this? This is me making an attachment for my what's it called? Industrial die grinder attachment system to put a flexible shaft on it. I'm creating a coupling system to enable me to use a flexible shaft as a kind of like a dentist pneumatic tool, to use it kind of like that to be able to grind things. They have what? I don't have it. What kind of AI will my seagull have? Well, it needs to know enough to be able to calculate wind trajectories and calculate the physics of flight and actually fly accurately in all weather conditions, shy of maybe, I don't know, a tornado. It needs to be able to have metal detectors to search for valuables on the beach and eat them. It's like wedding rings and stuff. It will eat the ring and then fly home and give me the ring. So I'll get lots of gold this way. And I'll get quarters and nickels and stuff. It'll eat coins. And it will need to be able to run around and avoid people, detect people. It will need to have GPS so it can know where it's flying. Oh, here we go. Oh my gosh! Put safety glasses on! No! Not true, but it'll be true. What happened? What? Why'd it get thrown off? It wasn't strong enough. That could have hit me right in the face. Alright, plan B. It would have been great, but it snapped. That's amazing, man. I can't believe it didn't work. I thought that epoxy is a beast. It's steel reinforced and everything. Okay, plan B. I need to find a bolt that will go through here. Okay. This was my original plan anyways. The epoxy was something I thought would save time. Well, the past 3 hours are now wasted. I guess it does show, though, that epoxy is not as strong as I thought. I mean, it's strong, but I just discovered its limits, I guess. Would have never expected to crack for no reason like that. I mean, it's not like I smacked it really hard. Alright, laugh it up, Neon, but you know what? No matter how smart I was, I could have never known that the epoxy itself just wouldn't be strong enough. There's no way to know that without finding out. The assumption was that the epoxy would be strong enough. Welding? No, I don't need to weld it. I just need to screw a bolt in and then couple from that. I just didn't want to try to find a bolt, so I thought it'd be quicker to make something out of epoxy. I guess I'll look for a bolt now. I'm counting on your hoarding skills. There better be the right bolt in here, Grandpa, who passed away last year. You won't fail me, Grandpa. I trust you. You hoarded your whole life so that I could do this project. Ooh! I think I found it. Oh my gosh, I think this is it. What? My hands are shaking, I'm so excited. I can't wait to find out. Will it go in? Oh, it works! Oh my gosh! We're in business, boys. Gosh. I'm so pleased with that news. Okay, so now all I have to do is cut the head of the bolt off so that my coupling will fit over it. And then we'll be good, man. We'll put the coupling on, the coupling that goes to the output shaft of the servo motor, or the stepper motor. And then we'll have created a coupling system, and then we can couple our flexible shaft extension to it, and we'll be good. That easy. I'm a genius. Never doubt a genius. 5 minutes after failure, I've already succeeded. My failure was only because I didn't design the epoxy putty. If I designed it, and I did the chemistry, it would have never broke. No, I'm not going through a stepper motor. These stepper motors come with aluminum couplings with set screws that enable you to connect a shaft of one size to a shaft of another size, and it takes a big range of different diameter shafts. So this way I can, once I smooth out the threads of the screw, I can screw onto that with this coupling using the set screw and make a real tight hold on it, and then couple that to the shaft of my flexible shaft, and then the flexible shaft will be ready to go. I can use it. Alright, I'm thinking ahead since I have to pull out my angle grinder again. I'm gonna need, I might as well do this other job too. This is phase 2. I'm gonna need I think a nail. I need something that will fit into this chuck. This chuck has such a small opening. What the hell? Why won't the... I don't even know how this chuck works now. It's not changing size. What the heck? I'm confused. Oh, maybe you have to hold this while you turn. What the heck? Oh, okay, it's turning the whole thing. Okay, I think I got it. This is just different. But anyways, there we go. So I'd be able to couple to this nail, and then from the nail we'd go to this here, and then from this we could go to a much thicker shaft, so that I can use my much thicker shafted Dremel bit, which wouldn't fit in this flexible thing. So that way we can couple out to a bigger one, because this chuck is ridiculously tiny. So that's a coupling system for the chuck. So I'm gonna grind the head off this nail and smooth out the nail, and I'm gonna grind the head off the screw or the bolt, and then we'll be good. The stepper is going to be unaffected. I'm just going to undo the set screws and remove this from the stepper. I'm taking it off the stepper. I'll order another pair of couplers to put back on the stepper for when I build my second 3D printer with those steppers. But for now, I'm just swapping parts from that 3D printer because I'm not using it. And I already have one working 3D printer. This is just a backup anyways. Okay. So we'll do both of those grinding jobs and then come back. I'm going to do it in the garage because it's going to shoot a lot of crud everywhere. So I'll be back. Thank you, Deodort. Well, at least we failed fast on Plan A. Plan B... Actually, Plan A was Plan B. This was my first way I was going to do it, but I thought Plan B would be better, faster. I just didn't think I'd be able to find the right bolt. The bolt obviously is the best choice. What am I doing now? I'll bolt the bolt I made in and see where that gets us. We found the bolt. Now we're going to put it in. Yeah, that's true. I mean, but, well, yeah, there is really no but. That's exactly what science is. I'm doing science, guys. I didn't fail. My hypothesis was incorrect. And it wasn't even because I'm an idiot. It's because I overestimated the power of the epoxy. Which is a fair thing to do. Ooh. Ooh! That's what happens when you have the mind of a genius. You think of cool solutions outside the box. Like using your clipboard as a vacuum holder. I visualized it, and then I did it. Creativity and powerful visualization skills, a deadly combination. This screw should become totally threadless in a minute. What the hell? I don't get it. I don't know what the hell is going on. It flattened one side. How is that even possible if it's spinning for it to flatten one side? That makes no sense. That defies my mind. Like... Okay, so this side went smooth, and then this side's not. How is that possible if it's spinning for one side to get smooth, the other not? That makes no sense at all. I don't get it. Something weird with physics just happened. I don't even know the mathematics behind it. I'm sorry, I'm not that smart. I don't get it. If it's spinning, why would one side get flat and the other get nothing? That's stupid. Just gotta do it by hand, I guess. Like, I just can't picture... Imagine a potter's using his hands to smooth out a bowl that's spinning very fast. And then he stops the machine and one part of the bowl's flat. How? How? The other side of the bowl's not touched. It makes no sense. Guys, a ghost just took over. That's not reality, guys. Sorry. My machine just did something that defies common sense. I guess at these high resolution revolutions, 26,000 RPM, nothing has to make sense anymore. Physics no longer apply. I crossed the space-time continuum with my die grinder. This is quantum physics at this point. Oh, maybe it was worn down because... I know this is going to sound dumb, but when I was using the file, if the timing's right, as the file hits it and grinds, it's going to bounce back down. And it's going to come up, bounce back down, come up, bounce back down. And each time it hits, it's going to be hitting at the same point in time during the revolutions, just scuffing that one part. So it actually happened due to the vibrations of it hitting at the right time. That's why it sanded down one side and nothing else. So it actually probably happened, well, it could have happened from either of the grinders, but it came down to vibrations. It wasn't maintaining contact. So I figured it out. That's so weird. That was a phenomenon. I don't know, I might have ruined it, I'm not sure. I don't know if it's still gonna work. The whole bolt's not straight anymore, I think. Oh gosh, I don't even want to think that way. Alright, I'm gonna try it. I'm kind of scared. Is that okay? Gosh, I'm scared. If this thing comes flying off, it's gonna freaking bust something, man. Putting it tight. Tight as I can. Screw this. Holy shit! Oh my gosh! I did not expect that. That shot a hole through my wall. That could have been my face. That would have busted my teeth out. Holy crap! This is dangerous! I had a feeling it was dangerous, but not. I never expected that. Whoa! I don't know what to do with this tool at this point. That was my go-to. Yeah, it's off balance. It's way off balance, but who cares? I don't trust a tool that's gonna break. I don't care if it's off balance. The coupling itself should be trustworthy, not to just snap in half like that. It only had to snap in this small little area. This coupling's not designed for this highest speeds. I could start all over with a new bolt and make sure it's better aligned and whatnot, but I don't trust this at all anymore. I'm starting to wonder. I'm starting to second guess the entire project. I'm gonna have to ask my dad what to do. My dad's actually super smart. He's not an engineer or anything, but he could have been, for sure. When we put our minds together, we're dangerous. Yeah. The bit needs to be smaller.
Right.
And those teeth can carve out. They carve
Right.
a good amount, right?
So this needs to be the size of taking away the threads.
Yeah.
It looks like it's the right size.
And yeah, well, I think, unless if you can find one closer in my other drill thing.
You can't lose parts or getting all discombobulated.
What are we missing?
Well, now, what do you mean other drill bit? This I got from here.
Well, I have more drill bits that might be a closer match. Maybe this one? They're probably the same.
Well, that's the size smaller.
But we don't want smaller? Or we...
I don't know. That's,
Here's another
I'm
one.
not convinced. Well, these
Same.
are the same.
Those are both smaller.
Now, it's one of these two. Either that one or it's just the smaller one. Well, these look the same. Yeah, these are, they're all the same.
That's probably standard. They're called M5s. It's got to be. That's got to be. They're all very standard. Everything seems standard here. You know? Because we've been trying everything, and everything fits everything that we've been looking at today. We got it clamped down a C-clamp, lined up. This is off center though. This is the top. This is the top, more like right here. But if you look at the bottom, it looks like. Because I thought, well, does it matter though? As long as there's three, do they need to be all equal?
Yeah, I don't think they need to be exactly.
That's better. You got it lined up now. Wait, you didn't tap it. You want to tap it with that first to mark your spot. You can use that as a hammer.
I don't want to get too close to the lip.
Is that where the others were? On the other side? Distance-wise, about?
That's about.
Would it be better a little more toward you, maybe? Maybe centered? Vertically?
Well,
Are those? No, those are a little more toward the lip than center.
yeah,
So you might have it down, right? That looks good, right?
it looks pretty close.
Yeah, it doesn't have to be perfect.
I don't want to lose this thing.
Wait, there's a couple things. One, I said drill on slowest drill setting in reverse for the bits. These might be reverse threaded. I don't know which one you took. The bits are reverse threaded, I think.
Oh,
Maybe. So check that. And drill on slowest drill setting. You can change the gear settings by cranking this left or right. Yeah, you want to go to the slowest, so all the way down to 1 or
that's
whatever.
fast.
No, that's slower. You can go down to slowest setting.
What's the slowest? The lower number?
1, yeah. That should be. What is the...
I'm not used to this drill. I'm used to mine.
Yours has no speed,
See,
though.
yeah, but
Control.
this doesn't tighten up very tight.
Well, don't break it. It's not going to slide around. It tightens tight enough to not move in there. Is it reverse threaded at all?
I've never seen a drill bit. You've got drill bits that are reverse?
Oh, maybe just the extractor bit is. I don't know. I just wrote drill on slowest drill setting and in reverse for the bits. That's my notes that I took. And I would think I had it right.
Well, the drill bit only drills a hole. Are you referring to this thing that it's reverse?
It says, look, 10-piece extractor and left-hand drill bits. And the fact that I personally wrote drill in reverse, then that's it, man. Now, I don't know which one you took. Does that look ever used? That looks unused, so that came from this kit. And this used one definitely was not from that kit. That was from my drill bit box. Because these are all used. These are old ones.
So those are different types of drill bits?
Those, well, a lot of those are wood screws, but I think the one you had put here was a metal one. But these are for sure, the ones here are for sure metal bits because they're made for extracting metal. It's an extraction kit.
Well, you want me to use this one? The same size.
Oh. Yeah, I didn't know. So you got that from there?
I don't.
Without telling me?
Yeah,
You sweat?
this.
Wait, no, because there's one missing then.
I just pulled this.
Where are you getting all this stuff?
Yeah,
Where did this come from?
these are regular drill bits. Drill bits are drill bits. There is no other different kind of a drill bit, is there?
They're left-hand bits from this kit. Oh, so all the ones with the silver sheen are left-hand bits. That's a left-hand bit. These are normal bits.
Well, we should be able to visibly see the difference then. I've never seen. Okay, this. Oh, yeah, you're right. They are different. And it go like, yeah, this is
Left-hand bit.
left hand. I've never even knew that.
You might want to use my
So
left-hand
this
bit.
one goes there.
Yeah, you might want to use my left-hand bit because they're a brand new, made for metal. Whereas these, I don't know if they're just wood, you know. So this will for sure work. I mean, the wood bits are probably for wood and metal, just no strong metal. This will go through anything, I bet. So it's made for it. Just put it in reverse, though.
Put the drill in reverse?
Yeah.
I never even knew this. This is all new to me. I never had a.
The only reason I knew that is because I used these before. Oh, and that's the other thing. That you don't start with the biggest bit. It's too hard. Well, maybe not. Oh, that is already the smallest. Never mind. Because if you were going to do this bit, you would need to work your way up. You know what I'm saying? You can't just start with a monster bit. But since this is already the small size, we should be fine.
Before I do it, we got to make sure. It seems like it's the right size.
That's fine. They're all standard. Everything's standardized.
Oh, that's fine.
Ha! Yeah, buddy. Hold on. I got a GoPro now. I never used, well, I've used it one time years ago. I usually use it only for kayaking. We're good now. I can film everything.
Seems like maybe slightly deeper. Because the center of those things, slightly deeper in. Maybe right here.
You're getting it. That's how you're supposed to do it, little by little.
Yeah, this has got. See, mine doesn't loosen up. Mine's. It's got that shut. Okay.
Did you fix it?
Now that's about the right.
Did you fix the off kilter?
No, that's not quite right. But let me get this hole drilled. I think it's going to be easy. I'm just taking my time.
Well, you're supposed to go at the storage head and go slow, so it doesn't heat the bit and wear out the bit. Almost there.
Almost there.
I don't like how the thing's cockeyed though.
I don't either.
What the heck happened? And you couldn't fix it? Anything you tried?
I didn't really try that hard.
That's cool.
Now we see if we can tap it. Or we want to drill the other one since
Here's the tap.
I never tapped anything before.
You gotta loosen it and then tighten it.
This is the tap.
Yeah.
Yeah. No, it should be handles or something.
That is the handles. You turn it like that, yeah. You can use both hands if you want. Well, line it up. You're going in cockeyed. What the heck just happened? Oh, it slid in the tap. You didn't have it tapped in tight enough. That scared the heck out of me. I thought it went
It
through.
was too big.
Yeah, I thought this was too small.
I did too.
I was gonna give up.
That's the one thing that I don't know.
It looks off. You got to bring it toward me more. Looks good from here. Looks perfect for me. Now let me read the direction. Oh, that's not for that.
Do I go clockwise?
Yeah. That was just those weird bits, but this is all normal. Oh, and then you back up after you start it a little bit. A couple of turns, then you back out and you blow it out, and then you go in again.
This is just so hard to know. I mean, I could go for it, but I'm just trying to be deliberate.
Yeah, might as well do a good job. Looks good. Looks really good from here. Just brought toward me a little bit. I think you just. I mean, in the end, your drill hole, your pilot hole will make the most difference. I don't think you have a whole lot of control with this phase.
Right.
Are you a machinist now?
I'm nothing until the fat lady sings. This is totally nothing.
That's not true. You've almost machined a hole.
I never did this before. You ought to be the one ruining your thing, not me.
Yeah, but I'm tired and I gotta be filming. You know, those couplings, if we destroyed it, they're only like $1. Because they're super popular for CNC machines, or for 3D printers.
Doesn't seem to be...
Going in?
No, it's the thing's crumbling. Oh, well, maybe there's threads. It just... Yeah, this stuff is so cheap.
Yeah.
I mean, it's not even real metal or something.
Well, it's foam metal. They add a lot of bubbles in it. It's foam.
Yeah, and I think the threads that we're making are even flaking off. I don't think this is going to work myself.
Oh, you know what? Then don't pull it out. Just thread it all the way through.
Yeah, that's what I probably should have did. Just
because you
kept
might have
going.
started different threads, maybe.
Right.
You got to line it up right.
See
before you
that?
take it
Yeah,
out.
that's what I did. I should have just kept going. That's what I did.
You got to make sure it's in the original grooves.
Yeah. Now it's. See, I gotta.
You can find the original grooves again, though. Wait till it feels right, and then just take it the rest of the way. I might as well.
I gotta get comfortable. Shoot, I don't have no confidence at all in this. I really don't.
Well, it can't be that hard, right? All you're doing is just turning. I know they took it out and blew it out, though. Blind leading the blind. Through them at this point? I don't know. I've forced screws into stuff wrong. This metal's so soft.
I
It
know.
might save itself if you push hard. You might be able to just self-thread it, you know?
Yeah.
I've done that in wood. Self-tapping screws. This metal's so soft, as long as you can start it, it'll probably go through. That's probably how they do it. Especially if they're a little bigger. And it's good you didn't finish it. The last couple threads, at least you'll have some good threads deep in there, right? The fact that it's boogered up, it'll just form nice now with that. I don't see what could go wrong now. Hey, and the fact that it's hard to turn is a good sign, right?
Yeah.
That means it's going to be very solid if you make it.
I need to get mine. Mine's tougher. This is gonna. Let me get mine out of my. It's in my tool.
I don't know if that's the right one, is it?
Yeah. Yeah, it is.
What was that?
That was the thing stripped out. You know what? Maybe now. We don't want to strip the set screw.
Oh,
See, it stripped it. So,
can you still get it out?
yeah, we can maybe get it out and then finish the tap. Maybe it's got better threads.
Maybe. You're just not tapping it square. You're putting in the tap cockeyed.
Gotta try to get it out now.
You're bending it wrong.
Sucker's in there.
It's not as strong like that. Use that as the cheater
Yeah,
bar.
but this is boogered
Oh.
up. See, it boogered up.
What's wrong with yours? Did it get it?
I don't know. Yeah, I got it.
We're having
Well, it's got threads. Maybe I ought to just try this a little bit more.
yeah, but gentle, and make sure it's in there good, so it feels good.
Right, right.
You were just winging it. Make sure it's home.
Yeah, I'm doing it very softly. See, it's a feel. I'm feeling for the threads.
And this time, go all the way. I think just go all the way. I've seen machines go all the way in one shot. They just right back out. Man, that looks off.
Do you want me to hold it and you do it?
Why is it wanting to turn me off?
Is it going in?
Oh. It doesn't go in. Why is that? That's what was happening to you, right? It will start and then it'll bounce back.
Right.
Well, what the heck? How about I hold it and you push down with all your weight? Right?
Well, no, I could get rough with it.
Do it.
Well, I was wanting to get you in on it. Maybe Hannah ought to do this.
Wait a minute. Why don't you put it flat on the table first? Like this. And use both hands to turn this thing while putting your weight on it. I'll hold it. Because I can't do much with my bad shoulders.
Here we go. We're getting it now.
Stupid
Oh,
thing.
that thing.
Thought you did it with both wrenches.
Here, let go of that. You gotta. Okay.
Yeah. So you just drilled it totally off. It's making it though. I bet you it's gonna work. Just keep going. I think your drill pilot hole is off.
Oh no, this isn't. It's,
What is it? I see the tap entering the middle. I see the point of it. You're almost done. A few more turns, it's
yeah, but
done.
see, this isn't turning the.
Oh,
the
you're
thing.
not in there.
I'm not in there.
So your pilot hole is way off. Look at that.
Well, now see, I got. What's going on?
Just back it out, and then you gotta move that down.
Well, I
Now
want.
back this side out. That's already backed out all the way.
Okay.
It's butchered.
Well, at least maybe if we get one in, we know it can be done, and then you can do it again.
I'm not doing it again. This was my...
Perfection.
No, this was us doing it. What the heck? Hey, don't back it up way at the bottom of the spring.
Yeah, I saw that right away as soon as you
Why is it
did.
popping out of there? Don't you have it in home? I thought you already secured that part.
This shouldn't be this difficult.
What's going on? Wait a minute, you're not... It forms a square, and that's a square. You got to make sure the walls are lined up.
Oh, I didn't know that.
Yeah.
That's a square.
Yeah. Now tighten it. It won't go anywhere. You got to tighten that side. This side doesn't move.
There. Now it's in the square.
Probably don't even have to make it that tight when it's in the square.
Right, maybe.
You know, it doesn't even have to be perfect as long as the set screw doesn't move, right? The point is to center it. We're going to pour solder in anyways, right? This is just our shim. Who the frick cares, right?
It's moving in this thing again.
What? There's no way.
Yes, it was. It's not moving this.
How's that possible? I got vice grips.
Looks like it's in.
How do you have it in if it falls right out? Don't you know how to tighten a screw?
You got some cheap stuff.
How's it cheap? Just tighten it.
Where'd you get it at, Menards?
Yeah? No, Harper Freight. They're top of the line, I
This
heard.
is like getting a Plumworks faucet.
What's the problem?
The problem is when I
No, I mean, why isn't it tight enough? What's making it not tight? I don't see why you can't just tighten it.
this okay, that's tight.
Obviously not if it keeps falling out. You don't even have the square lined up. It's on the edges.
Well, I had them lined up.
Not this time.
Well, why don't you hold it on the edges? I can do this. Man, I would never make a machinist.
Why not?
Because
Why not?
is that lined up to you?
No, it needs to turn counterclockwise till the teeth line up. You should have it
How about
feel.
this?
Yeah, it is lined up right, but isn't it too far out now? I can push it down. Yeah. You think it's unscrewing after you tighten it?
No, this is spinning in there. What I'm doing now is
I know, but if you have it snug on there, it shouldn't be able to spin.
I know.
So is it unscrewing off? Is this unscrewing, causing it to loosen up? Does it back out when you put
Well,
pressure?
watch. Well, no, I gotta hold this.
Yeah, we got 2 turns to go.
I know it's almost home. Now just watch everything. It seems. Okay, it's turning now. It's working. I'm gonna have chips all over my floor. There, it's working. Am I home?
Huh?
Should I keep going or stop
Yeah,
there?
there's no reason to stop. You can keep going. That will reinforce the threads really nice, right? We'll just keep them going. You'll see more and more metal coming out. It will just make it like official. I think it won't hurt at all.
Okay.
So we did it. That's a perfect drill and tap. Perfectly centered.
Well, is that a bunch of garbage right there you just said? It's not perfectly centered at all.
You gotta get your glasses checked.
Where's that thing?
There, it's in the tool stall. That's impressive that we did this, though. Right?
Well, we haven't did it yet. This is everything.
You're still from Missouri?
Yeah.
No wonder you doubt my robot. You doubt you can screw a screw in when you've already made the hole in threads. You doubt until there's not even any faith required. Where's your faith?
My faith is in something a lot more reliable than me. See, it seems to want to get hung up right there.
We'll send the tap through again. I don't know. You just had it. That's where the tap got hung up, too.
Unless the tap isn't this size.
Oh, you're kidding me.
Now I'll try the tap again.
That would be ridiculous.
Okay, the tap is fine.
All the way fine? All the way through?
Yeah.
And it holds, too?
Yeah.
So the set screw is different thread pitch. Should we try other screws? How the heck? What other screws could we try? That's not. This should go in like butter. If it's not going in good, then the threads are different.
Yeah. Well, there's threads there. Oh, it sure seems it should.
Do you think you boogered up the tap or the screw when we were messing with it? Let's try a different one.
Yeah.
It's probably got aluminum stuck in it.
Or it's stripped or whatever.
Yeah.
It's called. Yeah.
Try one from this.
Yeah, because we were gonna just tap it by using that, but it boogered that up. So let's try this.
You're just being careful.
No, it's a little sticky.
We got so they're just not compatible. We need other screws.
Well, I don't know.
I wouldn't mind putting other screws through.
I mean, are these? I mean, this machine's.
If we put another screw through, we could put it through, get it centered, and then just cut it off wherever it ends. And it wouldn't ever be able to come out again, but it's just a shim. We're going to drip
Right.
solder in anyways.
Right. Well, I can put this through now.
You can?
Yeah, I'm sure I can because it's a lot opened up more than what it was before. You know, I was drilling through no threads at all. Now it's threaded all the way through. I'm sure I can take this all the way through if you want me to.
Yeah.
Okay. I think.
Oh, that was stripping, right?
Yeah, that one. Yeah.
Your tool or the thing? When that happened last time, it wouldn't come out again. You should probably take it back out now.
Yeah.
This is frustrating. Oh,
You're back?
oh, I need to lay down. Oh,
What's wrong with your back?
it's aching real bad. Oh,
What's up with your body?
still in recovery, and I've been working too hard today. I already worked for 11. No, I've already worked for like 14 hours. I'm overdoing it.
This is ridiculous what we're doing.
I bet you. Try to find an M5 bolt, a small screw. I think that those set screws are just a non-traditional size. I bet any machine screw we have. I have a ton of screws in my blue container, and you threaded it perfect. A normal screw will go in. That's because threads can be different pitches. I think those set screws are a non-traditional thread pitch, and if you found a little screw from, your bucket or my bucket, it will go right in.
Possibly.
Then we'll be set.
Yeah, this is just going to be like a shim, right, for your.
Yeah, I wouldn't booger it up anymore. Just put the threader back in, make sure that all still works, and we'll look for a screw that matches.
Okay, I'm trying to get this out now. That's all I'm trying to do.
If you think it might be ruined, might as well grab it with the channels.
Yeah, or with my pliers. I'm thinking about that, but
Yeah, because we're not using them anyway. If they don't match the threader, then they're no good to us at all.
man, I thought your shoulder was screwed up. You're saying your back hurts? You won't believe what just happened.
The whole thing broke?
The set screw just busted in pieces.
What?
What kind of like cheap stuff do you got here? The set screw disintegrated.
But it's out.
No, I could probably be drilled out.
Oh yeah. Well, no. Well, maybe.
I can't believe that just happened. Now I'm really screwed.
What the heck? How could that happen?
Look, I'll bring it to you. We're screwed now. Look. Set screws aren't, that's, set screws, the set screws I got in that thing right there, you could take a hammer to it, it won't split.
We don't need it out. Everything we're doing right now is dumb anyways. All I have to do is solder to raise up that side and use the other 2 screws to center it. I just need a shim. We don't need to do this. All I gotta do is put solder where our hole ended.
Well,
Just build up that wall a little bit, and that brazing stuff will stick to this. And I can drill out and grind it out if I had too much. I can just fill this up and then grind it out, drill it a little bit.
you say these are easily gotten?
Yeah, 75 cents.
Yeah, so you might want to get another one, just so you got a nice brush.
Why?
Because it's banana,
But don't you just have to do?
maybe. I failed you. I failed you.
If I stuck an X-Acto knife in here and just pried apart that, would probably. Yeah, I think you can just play with it and pinch things and then put some brazing in it and then pinch the next thing and you can reshape it. And then from there, brazing in there, just brazing to fix everything. And then use the set screws and get it perfectly lined up by eye from every angle, get it tight, and then just fill it with brazing. And then do the same on this side. I mean, just brazing and then the good set screws, and we got it. Now that's my only one, but I have another one with my 3D printer, and I can order a second. And I can make the 2. So basically, that was an interesting experiment into using machining. No, not an experiment. We did it. We went all the way through, and the threads look pretty good from the inside.
They look
Got a
okay.
little boogered up because I think that you didn't catch it right with feel when you went back in a couple of times. So you gummed everything up. That was just impatience, just putting it back in quick. You were moving quick at first, and you weren't thinking about it.
Well, the metal was coming out. If you didn't tell me to do it, I would have just kept on going.
And maybe that is best, but I know they said not to, but maybe it's 10 turns then pull it out. But we did it after like 3.
Yeah.
You didn't have it deep enough to need to yet.
Right.
And not until it starts getting really bound up, maybe. And then they'll spray it and then go in again. They'll make real deep ones. Maybe something that small you don't have to ever pull it out. It's not going to get stopped up that easily. But you did it. You threaded, you drilled and threaded. And if we had the right thread pitch screw, we could screw. It's that they don't match. And I bet if you look close under some magnification, you can verify that those set screws don't match the thread pitch of the tap. Wouldn't you concur that they don't match in pitch? Or they're totally different sizes?
Yes, I definitely concur with that, because that set screw, even when I got the tap all the way in, all the way out, and I tried it again, that set screw is getting bound up, like after, like into the second thread. It's getting bound up.
He's not even in the track.
Right, he's not in the track.
So if we had a matching screw, it'd be nice. It would work.
So
The
that,
M5 screw.
that's what the tapping set says, M5? Okay.
Yeah.
Yeah, then that tapping screw wasn't M5. That would be my guess, because it should have worked. I went all the way through it, and it felt good. And you're right, I boogered up the first few, but there was enough afterwards, because I wiggled it once I got 4 or 5 in, and it seemed to be sturdy, it wasn't wobbly.
So this whole thing, we didn't come up with anything quick. Pretty much I'm sticking to my original plan, but I just need to true everything real good.
Yeah.
And I need to beef up the heck out of the couplings to make them tanks. I need to wrap it in I need to braze it to get rid of the spring fully, so it cannot bend. And I need to wrap it in fiberglass thick with epoxy, solid, thick, whatever it takes to make it a tank, so it's unbreakable. And if I do all that, it's guaranteed to work, right?
You use the word guarantee, positive for sure, I'm an expert. You use that so loosely.
Dad, you gotta trust your visualizer.
I see, I laugh because probably everybody else in the world would side with me on this. It's part of scientific method. My son says if you visualize it well enough, you don't need it.
Yeah.
Well, I know one thing. My kitchen is disastrous. I'm gonna vacuum that stuff up once your stuff is removed. But
Wait a minute. Listen to me real quick. You know what a D-shaped output shaft is, right? It's round, but then has one flat face, so it becomes uppercase D. And that keys to an uppercase D female, and they can't turn after that. So it helps things with when it comes to turning. I almost made pretty much an uppercase D with my bolt, actually, but what I have this idea is you screw the screw into the die grinder, which it fits perfect. Screw that in, and then we want it to attach to the little guy. What if I uppercase D the little guy a little bit, and then just start wrapping it all real tight, not with epoxy putty, but with fiberglass and epoxy. How did it break? It broke in half. It can't break in half fiberglass, right? Because fiberglass threads would have to tear apart. They can, but it's close to the strength of steel. Whereas epoxy putty, especially that hasn't had the full 24 hours to cure, is probably still pretty soft. It gets hard to the touch in 20 minutes, but do you think it was really cured that fast? It probably takes a couple days for it to get to its full strength. And it's probably stronger than that cheap thing. And the only reason that didn't work is because of...
Do you realize that because this is in a spring shape, the only metal, it just snapped off that little bit of metal and the whole thing came loose.
Yeah.
So, you know, just that, you can see it right there.
Yeah.
So you just didn't have a chance with this. So you're talking about fiberglass, getting that all in between all that stuff?
No, I was talking about creating a coupling out of only fiberglass.
Oh.
Wait, what if I actually did just weld it? What if I just stuck the two things together, got them just right, all home, and just welded the two shafts together? Weld it, then grind it, bend it a little, weld it a little more, grind it flat, bend it a little, get it just right, bend it at each angle, weld it some more, and just build up the welds until it's freaking the size of my fist. I see that break, son of a buck. That can't breathe. Should
I know
I?
one thing.
It's got to be better than that stupid thing.
This thing, I'm tired of looking at. I've been looking at this for 2 frickin' hours. Why? This can drive somebody insane. That's stupid. But this thing has caused me to spend more time with you this morning than I have in months. Wait, welds fail too. I welded a nut to a bolt that had snapped off. And I turned the nut and it popped off. It broke immediately. Welds frickin' suck. Well, maybe just the welds with my welder. If I had a TIG welder, those are professional. Those welds are as strong as an all-year welder. I got the cheapest welder, $80. A good welder costs $2 grand.
Guys, I'm not done with that power tool extension project. I will successfully do it. I already have a new plan in place, my 3rd attempt, and this time I will 100% succeed. This time I'm making everything. I'm not going to trust some idiot's supposed steel reinforced epoxy that doesn't work. I'm not going to trust some idiot's piece of crap Chinese coupling that's made for stepper motors and low speed applications. I'm going to custom machine my own metal parts and it's going to be perfect. I've been planning building my own sort of lathe materials to, not lathe, a jig and a drill press DIY. I have to make those first, I guess, to do this.